Ooh, hello, I'm doing the Sion intro. Doesn't Sion often start his streams with a cup of coffee or glass of coffee to his face? I think he might. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Oh, welcome everybody. I started with the lights off, mood lighting, so that you can't see how bloodshot my eyes are. I am so tired. So tired. Yes. By tomorrow, I have to have a bunch of stuff done for 4 different clients. I need to have some modifications done to a board, which is reasonably minor. I need to have assembled 2 prototypes. The bare PCBs have arrived. I need to revamp a firmware release system for another client, and I need to finish the design of 2 boards to go off to production in the next day or so. So, hang on, I'm just going to unmute this because Mitchell's toy is back. I had it muted at first because it was saying so-and-so has arrived for every single person. Okay. Oh no, Mitchell. I had it open, but I had it muted because it was just constantly talking with all of the new people appearing in the chat. So good.
Alexi Kohler said morning.
Yes, there it is. Alexi, it worked for you. I'll just turn the volume up a fraction now. So good morning to Mitchell, first of all, for this very fun toy. Keith, Chip, Amanda, Matt, who else? Gavin, Jack. I'll get back to Jack's comment in just a second. David, Luminator, Sharky, Gerald, Justin C. Dodgy is here. Chris is here. Delane, Russell, Graham. Yeah, awesome. Oh, and Graham had some comments about the loop area on the
David Crisp said open the pod bay doors.
on the
Amanda Thompson said good morning fellow superhumans.
on the loop area on the voltage regulator, and Jack had a comment about that.
Fellow superhumans.
Mitchell says, yeah, it's a switch, let me disable. Okay, cool. Okay, Dodgy asked, can you give us a visual signal so I take you off mute when you finish your blurb at the start? Okay. Like, I'm here. I don't know. Yes. Where are we? Did I miss anybody? I don't know. Maybe I did. If I did, I'm sorry. But thank you for coming along. Right. Okay. So I have... Oh, and the other thing was that about 20 minutes before the stream started, I realized that the batteries in my in my Magic Trackpad were flat, which is a real pain when it comes to doing PCB design, because I use pinch for zooming and 2-finger drag for panning all the time, just constantly. So when I'm doing board design, not having the trackpad is a real pain. So I quickly jumped in the car and went down to the local supermarket and got some batteries, and got back right before the right before the stream. So here we are. But there is something. There has been, as I've been doing this project live over the last few weeks, there has been this recurring issue of KiCad versus Fusion 360, and you've seen some of my frustrations with Fusion 360 electronics. I really like the schematic part of it. That seems fine to me. It's totally intuitive. It works the same way as Eagle. I've rejigged my shortcut thing on the on my Stream Deck. So I've got hotkeys for different tools. It's really good. The PCB layout part of it, I'm finding much more frustrating. There are so many little UI quirks. And then I opened the project this morning, right before the stream, and I saw this. Look at this little orange banner here. It says, for those of you who can't read it because it's small, on Sunday, August the 20th, that's today, from 11 a.m. to 12 p.m., that is in 54 minutes, Fusion 360 will undergo maintenance. Please check Health Dashboard for updates. In other words, halfway through the stream, Fusion may just stop working for nothing that I can do about it. It's presumably because in America, it's like Saturday night or something, so they figure it's probably, like midnight, Saturday night. I don't know what the time zone conversion is.
Mitchell R said, "Are you kidding us?" Autodesk ARG.
Yeah. Yes. So this is the killer of depending on software that requires something that is off your network and out of your control to work. Now, I'll probably be able to continue using it in offline mode, but it's just another one of those things that makes me so frustrated. Because if I'm paying for software, I want to be using it whenever I need to use it, not have it go down for maintenance windows when I don't even care. So, Jack says, yeah, that's normal with Fusion, and yeah, it's 8 p.m. right now, Saturday here for me. 7 Central Time, says the lane. Yeah. All right. Okay, so was it last week that was the barbecue? I think it was. It feels like a month ago. But after the barbecue, so at the barbecue last week, a whole bunch of people turned up, which was awesome. And I ended up doing an impromptu KiCad lesson, as in receiving an impromptu KiCad lesson during the barbecue. And so, yes, I'm going to, yeah, Chip says, it does feel like a month ago, but we're not on the doorstep. Oh, yes. So I ended up running KiCad 7 and getting a little bit of an introduction to a whole lot of things and the differences between it, and it is remarkably slick. So that also has helped me to tip slightly towards it. All right. So thank you to Mitch. It was Mitch who is a long-term KiCad user. I think I don't know how long he's been using it. Long time. From the very early days. And so he's got total muscle memory on all the keyboard shortcuts and everything. And so he took me through the process of what I actually opened was the PCB design for the Opulo pick and place machines feeder. The Lumen PnP from Opulo has electric feeders, and it's all open source. The design is all published, and the main control board that goes inside each feeder is designed in KiCad. And so what I did was I had the Opulo feeder control board open and deleted some tracks and went through a few exercises like what if I want to move these things around and how do I route this and how do I highlight nets and those sorts of things. And yeah, Mitch took me through it all, and it all looks really good. And another thing that was frustrating was during the week, when I say during the week, yesterday, so Saturday, but still, yesterday I was working on a client project and I wanted to put down a connector. Now the connector is a Molex, what is it, a Mini Fit Junior, but this is a Chinese version that comes from a company called XFCN. They make compatible connectors, and but it's all the same footprint as the Mini Fit Junior. And I went looking for things like Eagle footprints and information about it. And there is a KiCad library that has, I don't know, like 2,000 Molex connector footprints in it. Couldn't find it for a Fusion. I ended up making it myself because that's what I normally do. I just added it to my own connectors library. But it was another one of those situations where the critical mass of content and information and projects and reference material and all of that sort of thing, it used to be that there wasn't very much for KiCad, so you really were starting on your own from scratch if you jumped into it. Now it's what everybody's using, so I follow the crowd. Critical mass. Graham! And I'm back. Where did you go? Funny. Coso de Robotica said 10:08 a.m. here in Sydney. Yeah, I think you're in the same time zone as me. Where am I? Where am I? Okay, now 2 points to follow up. One is, if we jump back to here, and where's the power supply for this? There, power in 5-volt regulator. All right, so LMR 38020, and what I've got here is I basically this was my circuit from the LMR 38010, and I just duplicated it, and all I did was change the part number, I think, and also the inductor needs to change. So it's a 33 microhenry inductor if you're doing it with an LMR 38010 to get 5 volts out at 400 kilohertz. And I haven't actually changed anything, and in fact I hadn't even checked the data sheet. So let's see, LMR 380, do I have the data sheet here? I think I do. There is the 38010 data sheet. I'll open this, and then do I have, this is riveting, isn't it? I don't have the LMR 38020 data sheet locally, so I'm going to have to open it. So this is the 38010 data sheet, and if we go, where was it? Down in the, oh, there's the, the suggested layout that Graham has been having issues with, so we might look back at that later. Somewhere, where is it? Somewhere there will be a an example. Here we go. Typical application. Okay, so we've got L in this case being, whoa, what was that? Something just made a lot of noise.
Jack AF5IX said it will be table 9-1 on the sheet for both. Actual page 19.
Cool. Thanks, Jack. So yeah, this is actual page 19. Right there. So this is showing the value. So 400 kilohertz, 5 volts out, 33 microhenries as the inductor. That's probably a bit on the small side, isn't it? No, not that much. So this is what I had on my, oh yeah, and we can see here the feedback resistor, RFBT and RFBB, 100K and 24K9. All right, so what I had not even done was look at how that might be different in the LMR3. Here we go, LMR 380. Yeah, I type good. Data sheet. Data sheet. Data sheet. I will get there. And I will bring this up on the other monitor. Save. I'm going to grab this PDF and save it locally. And come on. Open. I just wanted to open it in a PDF viewer, not in... come on. Where is it? LMR. Here we go. This will get it. Alright. So, in fact, what I'm going to do is bring it up so that we can see both at the same time. The top... The top is going to be the values from the LMR 38010, and then here I'm going to go to actual page 19, where, well, because Jack found it for me. Here we go. So Oh yeah, I need to change the value of the inductor. Bring this down to the bottom part. Here we go. And let's do a quick comparison. So, choosing switching frequency. Oh, did I lose the page? What page am I on now? 20. Here we go. Alright, at last. My face is in the way. I'll get rid of me again. So, 400 kilohertz. First example, we've got first row in each table. We've got 400 kilohertz switching frequency, 48 volts in, 5 volts out, 33 microhenries. And for the 20, we have 400 kilohertz, 48 volts in, 5 volts out, 15 microhenries. The resistor values are the same, so it's 24K9 100K and 24K9 100K. The capacitor recommendations are the same. So the difference is just the inductor. It needs to be a 15 microhenry instead of 33 microhenry. So now if we come back to here and go value boink, 15 microhenry, and that is, what is that? Let's just check if that is a specific part number for I think that is an entire range of inductors. It's not one specific one. Yeah, that's right. Now the thing is, I've actually already bought that. I did check this on the datasheet. I just hadn't changed it in the schematic. I hadn't got to that point yet. So where are we? In fact, I might even have it here. Do I? Don't I? No, not there. I'm pretty sure I do over here somewhere. Because I bought a whole bunch of, I bought the parts for this. I ordered these. Where are we? Is this it? 15 microhenry, yes, here it is. And the 38020. Groovy. Coming back. So this is, before I hold it up, I better check if it's got my address on it or anything. No, the individual parts bags don't. They've just, oh, it's got a customer reference, which is nothing. Yeah. No, it doesn't show anything. So this is the LMR 38020s that I ordered, I don't know, a week ago. And this is the 15 microhenry inductors. So we are okay. Let's go back to preview. Yeah, 15 microhenry is what we need here. And I have them right here. Now hopefully I haven't missed anything else. It is possible that there are other differences between these two and that I've screwed it up, but hopefully it's okay. Did I miss anything, Jack? It was Jack who discovered my my oversight on this, so yes. Yeah, so Jack, please let me know if there is something else that I have missed on this comparison. Switching from the 1 amp version to the 2 amp version. As far as I can tell, yeah, cool. Thanks, Jack. So it was just the inductor. So as far as I can tell, the only change, basically these two are footprint compatible, and the rest of the supporting circuit, the feedback circuit, all of that sort of thing should all be the same. It's just the inductor which is different. And of course it needs to be a higher current rating. So the 15 microhenry inductors that I ordered are a higher current rating than the ones I used on the 1 amp version. They're actually physically exactly the same footprint, and they are from the same series, but they are, yeah, it's the VLS 5045 series, but it's 15 microhenry at a higher current rating than 33 microhenry. So, all right, I think we are good on that. Thanks, Jack. That was a good pickup. So Graham was talking about the layout. I'm going to sneeze in a minute. Oh, that came on more quickly than I was expecting. You know, you can often tell a while in advance when you're going to sneeze. And this time I had like 2 seconds warning. One, two. Ah, that was a confusing one.
David Crisp said blah, blah, blah. Blah, blah.
Okay,
Blah, blah, blah.
down, down, down. Okay, is that better? That was a really weird one. That was actually the mute button on the radio mic, which was in my pocket. And because I got up and moved around, when I sat down, it pushed the mute button. All right, I've got to keep it out of my pocket and clipped on the outside. Okay, so right, so back to this. So this is the layout basically taken from the datasheet, and what Graham was just saying is that he measured the loop distance and it was greater than an inch, which is approximately 25.4 millimeters, give or take. Oh, and Graham, yeah. Oh, and also, only thing I can see from the datasheet that doesn't match yours is they recommend multiple caps in parallel, and yours just has one MLCC plus one electrolytic. Didn't see if they recommend multiple MLCCs. Yeah, they do. So where is that in the schematic? Why didn't I drop them all in there? That is weird. Okay, I'm going to show you. What can I show? Yeah, I've used this. I don't know why I didn't do that. I'm going to just take this off screen for a second and open something else up, because I'm going to show you part of a client project, and I'm going to do it in a way that you can't see all the context. It is yes, just opening it up. Come on, Fusion. Okay, there's an opportunity for some more coffee. I've only had half my coffee. It's hard to drink coffee when you're talking. Ugh, and now it's nearly cold. All right. Now this will be okay. I can show you this. This is how I've implemented this. This was actually an LMR 38010, so it's the 1 amp version, and this is how I implemented it on a project for a client fairly recently, and you can see that it's got yeah, lots of caps. So these that's the input side, you can see there on the left, and the 5-volt rail on the right, the output side, and it's just got a whole bunch of surface mount caps. So that is what I was expecting. That is what I would have thought. I'm surprised that I didn't do that, basically, is the point I'm making. Why did I not do that on the other one. I need to add more caps in. You're right, Graham. This is cool. It's like it's a little bit like pair programming. We have someone talking through things as you're doing it. So what I used in this particular case, just because of the parts I had available. Now this is that same project, but this is the board layout view, and you can see and it's only the top layer. Other layers are hidden. So what I've got is a whole bunch of 10 microfarad caps in parallel on the input side and 22 microfarad on the output side, and that was just for voltage reasons. So for anyway, yeah, it came down to what I had on hand, what reels I happened to have when I was doing this, because the 22 microfarad caps that I've got here are rated to what is it, 16 volts, I think, and the 10 microfarad caps I've got are rated to 35 volts, and I was derating on the input side, so I used a bunch of 10 microfarad caps instead of 22s. But according to the data sheet, what I should have done is put some 22 microfarad caps on the input side, and I didn't actually need that many. And then I wouldn't have needed so many. So, what am I doing? Let's close that. Get rid of that. Where are we? Okay. What am I missing in chat? Okay. So, oh, Dave. Okay, I just saw Graham's response. David asked the question, why recommend multiple caps instead of just one big one doing all the work? And Graham answered that, which is ESR and ESL. So ESR is equivalent series resistance, ESL is equivalent series inductance. So Graham's excellent answer is multiple caps keeps the capacitor impedance lower and reduces self-heating effects. Also helps because the MLCCs have DC bias derating, probably very hefty at 12 volts in. And Graham said, oh yeah, so your DC bias derate is going to be pretty massive there. Yeah. Okay. All right. Brain fade. Brain fade. I haven't actually done anything yet. It's 10:29, and I might get a notice sometime from Fusion saying, oh, Adonis made it. From Fusion saying that, yes. All right, so let's throw in some more caps. Hang on, I didn't get a notification. Oh, maybe Mitchell's turned it off. I think Mitchell turned off the notification from when people arrive. Simon's here as well. Good morning, both Don and Simon. So what I need to do is throw in some more caps. More caps. All right, we've got a... Why have I got a... This is what happens when you copy and paste bits of schematics from other projects. Look at this. I've got a 220 microfarad electrode here. I've got a 330 microfarad electrode here. What I actually have are 220s. I've got a reel of 220s. So let's... This is designed based on what is lying around in the lab, not necessarily based on what is optimal for the design. All right, so I need some more, and that, let's make that a 22 microfarad because I have a whole bunch of 22s. Oh, and it says 50 volts. We don't care about a particular voltage rating. Well, we do. It just has to be high enough to be on a 5-volt rail. So let's just remove that voltage rating there, and likewise, let's make this one 22 microfarad because I have plenty of those, and I'm pretty sure these are 0805. Yes. So where are we? Let's, I need to make some more space or restructure this schematic. It's not ideal. I do like the idea of having the various stages of the power supply all in a line like this, starting with power in on the left and ending with the 3.3 volt rail on the right and the intermediate rail in the middle, the 5 volt rail, just because it makes it really clear what the flow of everything is and where the power is coming from. But it may be necessary to split this up just to make it all fit better on the schematic and to yeah, whatever I'm I don't know. Let's what do we need? We needed some caps on the output side and on the input side, so let's just move this across a little bit. What I could do is just have another block somewhere with a bunch of caps. That might even be the easiest way to do this. It's not ideal from... David says put it on an A0 sheet. Oh, Stephen
W said C2 to 22 UF.
C2. Oh, yeah, thanks for pointing that out. But in this case, I am not going to. What I'm going to do is leave it at 10 microfarad and say 35 volts, because I don't currently have 22 microfarad 0805s rated to that voltage. I want to be able to feed 12 volts into this, and oh mate, no. I'm just wondering. I don't actually even remember what the voltage is of the 22s that I have. I have a feeling they are 16 volt rated, and that is cutting too close to the wind to have those on a 12 volt input here. So I'm going to put 35 volt 10 microfarads there because that's what I happen to have. Now, what am I doing? Okay, let's be lazy about this. There's no more room on the schematic. Maybe I need to restructure my sheets a bit. Well, this one, where's the zoom command? There it is. This one has heaps of room on it, and I haven't even finished adding the nets there. All right, let's fix this power supply thing. At least get this sheet so that it's can be considered to be pretty much final. That designator. Oh, come on. Come on, I'm trying to pick that designator up. Why won't it select? All right. Is there going to be room? Yeah. Let's stick another one in there. And But what I should do, maybe, I don't know, you can tell that my brain is going backwards and forwards on this, and it is really not functioning very well. Let's swipe some more of these, boink, 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 and stick them down here somewhere. Doot, doot, doot. I need to find somewhere better on the schematic to put these. I really don't want them to be on the different sheet. It needs to be on the same sheet as the power supply to indicate that these go near the power supply. But for now, I am just going to put them here. Oh, excuse me. Come on, come on. And these ones go on the input side, and that's on the 12 volt rail. I think. No, it's not. It is on, that was wrong. It is on this, which is on the inside of the diode, and what am I going to call this net? I'm going to give this one a name. just so that I can reference it. What is it called? It's probably got some N$27 name or something like that. Oh, VN Plus. Okay. It does actually have a named net already, VN Plus. That's cool. So let's do this. Brink, brink, brink. And we'll stick a label on there. Where are we? Where's the label tool? Why can't I see the label tool? It's because it's right here somewhere. Where is the label? Oh, I've got the label tool selected already. No, I don't. Done. Okay, I've got to get out of that to get the label tool. Oh, little UI quirk that annoys me. VN Plus. VN Plus. Oh, I like this. This is something that I haven't actually checked if KiCad does, but I really like the way that Fusion 360 acts kind of like an IDE with auto completion. So I'm going to assign a name to this net, and if I start typing, so I just type V, it gives me a drop-down list of all the existing nets with names that start with V. And then if I type I, it narrows it down, and I can say, yes, I want it to be that one, and yes, join it to that net. That is really cool, because that helps reduce errors if you're trying to link nets together, because, yeah, it already knows what nets exist, and it just lets you choose from it. So that is nice. I do like that. No, not that tool. That tool. Move that there. What am I doing? I don't really love this style of... I'm jumping around all over the place at the moment. I really don't like not having these caps in this part of the circuit right where they need to be. They should all be lined up here so that you can see very obviously from the schematic that these are the caps on the output side of the regulator. And there just isn't room for it here with all of this. So I think I'm going to do a bit of a restructure. What can I do? That... where are we? That. I might even go to 3 sheets. I think I might need to. Oh, okay, so where are we? Okay, catching up on chat. Stephen asked, are your 330 microfarad caps low ESR? I think they are. They're ones that I haven't actually looked at the specs of them for a long time. I've used them on many projects, and they've gone onto, how many boards? I don't know. A very large number of boards. And I originally spec'd them for use in power supplies that were going in. So they were actually originally spec'd for the water cannon project, and then I've ended up using them in many other projects. And there were a few requirements. One was they had to have a long life. If you look at the data sheets for electrolytic capacitors, because one of the well-known problems with electrolytic capacitors is they dry out. They have not really liquid. They have an electrolyte inside them, hence the name. And when you see old capacitors on, old PC motherboards and in old TVs and things that have been left turned on for like years of being powered up, and the electrodes dry out, they can expand, the tops on them start to bulge, and they stop capacitating after a while. And capacitors, so electrolytic capacitors, one of the major specs for them is their operational life, normally in thousands of hours. And a typical electro, it's really surprising. If you just grab a normal electro, they often have a rated service life of maybe only 2,000 hours. Oh, Mitch says, oh, morning Mitch, says, sorry Kika, it doesn't have autocomplete for net names, but it would be a good feature. Yeah, yeah. It's one of those features that I didn't even know I would, it never even occurred to me that it could be a feature until I started typing a net name in Fusion 360 and it gave me a drop down list and I went, oh wow, that's awesome. So up until like a week ago, 2 weeks ago, never even crossed my mind that it could be a feature. And now that I've seen it, it is really, really cool. So if Kika does implement that, that would be really good. So hang on, I'm missing. That's right, I was off on a capacitor rant. So let's do the calculations. I've got the old school calculator here. So 2,000 hours divided by 24 hours is 83 days. So divided by, like, just say 30. It's 2 3/4 months, which is ridiculous. So if you now, hang on, I got a cough again. So if you use a standard spec electrolytic, they are rated for continuous operation at their rated temperature for 2 3/4 months. So under 3 months. That's really, really bad. So if you really start looking around, you can find some caps that are rated to 10,000 hours, but that's like kind of the upper range of what they are designed to operate for. So there are factors, if you want your electrolytics to last, there are a couple of things to consider. You've got to run them cool so that they don't dry out as much. And, well, that's probably the main thing. And you have to look at their operational life, and you have to look at their rated operating temperature. And if you find ones that have a high rated operating temperature and then you run them cooler, they will last for longer. So it's just one of those things. Anyway, my point of all of this is I looked into this quite a bit when I was picking capacitors way back ages ago, and the 220 microfarad, the 220 microfarad caps that I use, that I have many of here, I picked specifically for those characteristics to go in an ECU mounted on a truck in the sun, running in extreme conditions for long periods of time. And so they're pretty decent ones. So where are we? Graham says, maybe split off the power in section and then keep the 5 volt and 3.3 regs in a row. Yep, that's a good idea. Or move power onto its own sheet. If you need that many, turn them 90 degrees and run a line down from the top on the left and down on the right. You can squash in quite a lot that way. Okay. Yeah, Simon says, can you change sheet size? Yeah, I could, but then it just wouldn't look good printed on A4. Johnny is here. Okay, so more suggestions. Keith said, how about fitting them in and staggering them vertically so the text doesn't overlap? Yeah, I've done that before on schematics as well. And I'm not a huge fan of it, but that does work. Graham said, I just rotate them 90 degrees and run them between vertical wires in that case. Yeah, so rotate the designators and the values, or just the values because they're the long ones. Yes. Mitch says, do a reorg, perhaps squash down stuff on page 2 and move the power stuff to page 1. Graham says, so this is suggesting longer life caps. Solid Lu poly caps for the win for this reason, just a bit more expensive. And Jack said use polymers if you're worried about that. Yep. Graham says tantalum is also great now. They don't catch fire anymore. Tant poly specifically, but all the tier 1 cap manufacturers are making tant poly these days. Stephen says tantalums do still explode if you place them backwards though. That is true. So don't put them backwards. Right. Yeah, Tony said, found with high voltage capacitors, as in 11 kilovolts, reduced voltage by 10%, doubled the life. Wow. Yeah. Okay, so that's the other factor, is voltage derating makes a big difference. If you're pushing caps up towards their spec, basically anything that is worked hard close to its design limits is not going to have a great life expectancy. So if you keep them at lower voltage than they're rated to, lower temperature than they're rated to, then they'll last longer. John says, could he not annotate CXN, so caps times number? That's an interesting question. I don't think I've ever seen that done in a schematic. Maybe that is a thing. I just don't think I've ever seen it. It's an interesting idea. Okay, reorg. Let's reorg. I am going to, what am I going to do? Power in, yeah, I like Graham's idea of separating power in, bringing these down. I think I need a power sheet, perhaps, and separate out. So I'm not going to fit, I'm just doing it like a quick area calculation here. I am not going to fit all of the stuff that's on this sheet on the same sheet as the USB hub. The USB hub is huge. It takes up a lot of space. So maybe what I could do is hand interface piezo, Kayo serial microcontroller. Yeah. Let's just make a new sheet for now, and I'm going to let's put a frame on it. Boom, because I like frames. And what are we going to move there? On the first page we could keep, I think what I might do is move the power stuff. So I'm going to, also something that I just discovered. Now one thing, this is another thing that I haven't been able to figure out how to do in Fusion, is a marquee selection around an unusually shaped thing. So if I go to the group command, the group tool, which I've now got selected, I can grab, I can do the grab thing. But in Eagle I used to be able to do just click and then click and click and click and it would do straight lines in between. So you could then work your way around. Group is empty, yes I know. You could work your way around an intricate shape and select just a thing that you wanted to do, just the things you wanted to do. And I don't think you can do that anymore in Fusion 360, which is a big limitation. So what I'm going to do is select this, because I'm going to move it, and then I discovered that if you you can do the hold down shift and select things. So if I hold down shift and go click, click, it's now adding these to the group. It just deselected everything because I clicked on something even though I was holding down shift. Oh, that's annoying. That's bad behavior. Bad behavior. Fusion. Alright, select that again. Hold down shift and do click, 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 click. And I should be able to then move all of these. Oh, I did it again because I was too far away from the origin point on this. Oh, so annoying. All right. Yes. Okay. I'm going to do it in 2 stages because I am fighting Fusion and I don't want to be fighting. So I'm just going to move it down to here. stick it there, come back to this one, move that label there, grab these, move these, stick them down here, that'll do for now. So what have we got here now? Move tool, move that over here. And those are now all on a line. Better. Alright, so now we've got the USB hub on the first sheet. Second sheet is still currently a jumbled mess of random things. And the third sheet is our power related stuff. Now, what am I going to do here? Alright, I am going to, firstly, I'm just going to grab these, move these out of the way somewhere. Then, let's, let's make this a 3-stage thing. I don't know if this is going to work or not. Like, I don't know if it's visually going to work. Oh, that net rubber banding is not great. No, I don't want to merge it. I was just trying to move this. Now, can I select that and move it up? Yes, I can. Okay. Oh. Yeah, that net rubber banding is not good. Let's get rid of that because it had the, yes, merge that into there. All right, move that. Why it, yeah, okay, that's better. That to there. And that, in fact, to avoid this rubber banding problem, I'm going to preemptively get rid of these. I'm going to move it and then relink it. Something like that. Alright. And the only reason this was high was to make it the same height as the other, so let's bring that up. Alright, so we now have a 3 volts, so what have we got? Got a single 22 microfarad and a 220. It's probably okay, but I think I'm going to stick another stick another one of these in here, and this, yeah, I know this is ugly. I'm gonna check this out later. Maybe, yeah, okay. I do like showing the direct connection, but let's do something a little bit different. I'm going to take the take a 5-volt symbol, stick it here. Yes, merge it. So we've got 5 volts coming in on the 3.3 volt and 3 volts out. And up here, what is that one? That is V in plus. Get rid of that and that. And oh, I'm gonna have to move these things around a bit later because this spacing is not really working. But anyway, this is where it's going. I'm gonna have to clean all of this up. Yeah, done. Come on, give me the tool. Give me the tool. V in plus, and I'm going to name this one V in plus. Yes. Oh no, I hit the delete tool. Why didn't you notice that? Okay. I don't have a supply symbol for VN plus, so this is what I'm doing as a temporary thing. And then, what have we got here? Now we've got heaps of room, and now we can move things around. Where is the zoom? There. Yeah, so now we've got heaps of room and we can put things in nicer places and fix them up. Alright, power in. Here we go. We'll begin the cleanup. Oh, and all of this can be shorter now. So we've got VRAW coming in. VRAW is 12 volts DC nominal. We've got 12 volts coming in on after the fuse. So it's fused, but it is not polarity protected. I think that is acceptable. I don't want to be passing everything through this fuse. The other way around actually, if this comes in, because this could potentially be power coming from the CAN bus, so then it goes through the diode. Yeah, okay, that'll do. Yeah, I think it was Keith who suggested earlier staggering the caps. Yeah, that was a place where I had them staggered. So yeah. Yeah, the rubber banding weirds me out. It's strange. What do I need on the input side here? So I've got a bulk electro, I've got a 10 microfarad and 100 nanofarad. Let's just add this up. I'm not being very scientific about this. It's like, oh, does it feel like enough capacitors? It kind of feels like enough. Yeah, and all of this can come up, because we're no longer constrained by the height of the voltage regulator part of the circuit. Alright, so this is just the power in section, which gives us our VN plus, which is polarity protected. It's got a bunch of caps, and that's about it. In fact, move these up. Yeah, no, I won't. Come on. That'll do. That'll do. So now we've got a VN plus. Okay. Now VN plus, let's move all of this across. Give ourselves some more room to work with. Go away. Just like that. Bring this back across here. And that is going to be our input side. Alright, so VN plus is coming in on the input side. We've got the frequency set. We've got, let's move this. That note is actually from, yeah, that's not relevant anymore. That current rating is based on, like, it varies in the VLS 5045 range depending on the inductance, and the 15 microhenry one has a higher rating than the 33 microhenry regulator. So where are we? All right, now we're back to kind of where we were before. So now, in fact, I'm going to get rid of these. No, not move. Let's delete. Come on, delete tool, delete group. And instead, I'm just going to grab some more and stick them in here. All right, this should give us more of what we needed. So this means we will now have four ceramics and an electro on the output side. Let's move those up to align them. with the electro, bring that out, bring that around, and now we're getting a bit closer. Oh, Aaron said save before it goes offline. All right. Oh, we've detected an unexpected outage. Too late. Yeah. I can't save. Oh, Graham says, I think the save bot may be balked. Yes, let's see. I'm going to reload the save bot. Oh, bad gateway? What is... Ooh. Oh, okay. It looks like it's balked at Mitchell's end, perhaps. Scott says, must be a sunny day. Cloud has failed. Yeah. All right. Now, I'm just going to... While I'm... I'm just going to give a... give Mitchell time to have a look at what's going on with that and read the... read the chat. All right. So Graham says, I got to say, coming from Altium, this looks kind of excruciating. And then somewhere just below that, oh yeah, Scott says, coming from KiCad, it looks excruciating. Oh, okay. An important update from Simon. Simon said, just a quick note, my cancer has not grown nor shrank, meaning I have chemotherapy for the rest of my life with current situation. However, struggle with life, it is good to have live chat with all. Wow, that's a difficult situation to be in. Chemotherapy indefinitely. So does that, I guess that means you just it's like a holding pattern where the chemo is preventing it from growing, but it's not actually killing it. So you're in this limbo situation where it is there and not growing but not going away either. Oh, Simon, that's tough. I'm really sorry to hear that. It's yes, and it is good to have you here in the chat. Live chat is good. Well, my thoughts are with you. I really hope that you get through that situation okay, and you're dealing with it okay, emotionally, etc., as well as from a practical point of view. Doing chemo indefinitely is going to be rough on your body, so yeah, best of luck with that. Okay, so Trady asked, this was actually a question to Scott, how many hours do you need to put into the program to see results? Half my drama with KiCad is getting the right libraries and confused me as a newbie. Yeah, when I tried KiCad, I think it would have been in the version 4 series, and then leading into the 5 release, which was like a pretty major change, I think. I found that the way it managed its libraries was quite annoying, but that could have just been my my preconceptions. So I don't know if it actually was bad or if it was just me not understanding the what's the term? I don't know. I've lost my words. The paradigm of how it manages its libraries. So I found the libraries really, really annoying. But maybe it's different. Maybe it's better now. Maybe it's just that I was not in the right headspace and not understanding it, and maybe I would do better with it now. So that's one of, yes, the libraries in KiCad were something that I found were a barrier to me when I was experimenting with it around version 4, late version 4 releases and version 5. So Graham said, time for a crap load of capacitors. Capacitors, yep. Scott says, I started out with Eagle, then actually started being productive after scrapping that for KiCad. Yeah, Scott says, have gotten into the habit of just grabbing symbol, footprint, 3D sets for new things that aren't in the default libraries. And I keep a set of custom libraries in my projects folder. Yep, cool. Right, so Graham said, to be honest, I'd ditch C17 since 100 nanofarad is going to be kind of useless that far away from any actual parts. Yeah, that's true. It's a very small value, this one, yeah. Let's just kill it. And I should do a quick review to myself. What did we have? Okay, so on the input side, we've got a couple of 10 microfarads and a 220. What I should do is I should move. The zoom thing is frustrating. And that is one thing that I do find frustrating about KiCad, is the way it manages its canvas and moving things around is pretty much the same as the way Fusion does it. And I don't like it. Don't like it one little bit. So what I'm going to do is I'm going to just delink these. Let's see. I'm just going to try reloading Mitchell's talkie thingy again. No, it still says it's got a bad gateway on Cloudflare. So I'm not sure what's going on with that. All right. Yeah. So this is what I'm seeing when I try to load Mitchell's funky talkie thingy. Now you can all see what the URL is. I probably shouldn't have done that. What am I doing? What am I doing? Moving caps. So what I want to do is associate these caps, even though electrically it's exactly the same thing. I want to associate these caps with the input side of the switch mode regulator, because that is actually where it matters. Get rid of that and that, and move that down there. So, all right. So power in. It's just got a big fat electrolytic on it, and that's it. And then down here we have, yeah, maybe I'll stick another one in here. Move these up, and boop, boink, boink, boink. Join these in. Yeah, I need to renumber at some point as well. Alright, so now those caps are associated with the input side of this regulator, and these caps are associated with the output side. Do I need 4? Probably only 3. So what? I'll leave it in. Now it's like capacitor city around the 5-volt regulator. Okay. 400 kilohertz, 15 microhenry. It's been a whole lot of messing around and not getting anywhere. Oh, come on. Move group, there. And not getting anywhere very particularly fast. Okay, so 3.3 volt regulator. Got a couple of 22s on the output and a 220. That'll do on the 3.3 volt regulator. Oh, the zoom on this is just, the canvas management is horrible. Okay, because that is effectively the same thing. That's the 5 volts that comes into there. Yeah, that'll do. I think that's kind of acceptable cappage on the on the voltage regulators. All right, now back to the chat. Let's see what else is happening here. Scott says, doesn't upset me much to have custom libraries for things, since I find that I'm the only person on the planet that designs symbols and footprints that make sense. Yeah. Oh, Simon says, biggest problem is hands do not work well. Oh, you're having an effect. Yeah. Oh, Simon, I'm sorry to hear that you're dealing with this. Aaron says, coming from paper and pencil, it looks excruciating. Scott said, this is in relation to libraries. Scott said, as far as I've noticed all along, KiCad library management is no better or worse than Eagle, just different. Yeah, that's quite likely the case. Ooh, the audio gateway is back.
System connected.
Yes.
Activating the super house. Squirrel.
Cool. All right. We have the audio back. Oh, Mitch says, although KiCad has come streets ahead since V5, library management isn't much better. Mitch said, suggestion to me, keep a list of things that bug me about KiCad. For example, wish it had autocomplete on net names. The KiCad developers like to hear about it, and it's common for suggestions to be accepted. Yeah, cool. Simon asked, when is the next barbecue scheduled? Well, the barbecues are on the second Sunday of the month, which means, so the last one was on the 13th. I am just looking at my little calendar now, August. So the next one will be on September the 10th.
Mitchell said, sorry, I had to run out about 30 or so minutes ago due to a generator failure at one of the security sites I run. No dice, it's going down, sad face.
Oh, no worries, Mitchell. Yeah, I hope you get that problem sorted. So to answer Simon's question, the next Superhouse barbecue will be Sunday the 10th of September, which will be the second Sunday of September. Dentistries says?
Dentistry said, can't wait for the robot next week.
Yes. I will mention that in a little bit. Yeah. What have I been missing? What have I been missing? I don't know. Simon said, do you think, John, this Kayo PnP protocol converter is ever going to be completed? I don't know. Not at this rate. It is really, really slow doing things. I tell you what, this would have been done a couple of weeks ago if I wasn't confining it to live streams. Because a lot of the live stream, I'm kind of just talking through things and not actually getting on with doing the job, like right now. But it is for the chats. I come here for the chats, not for necessarily being super productive. Yeah. So, oh damn, Mitchell said, didn't even get through half of my coffee. It's cold now. So is mine. I've been wanting to keep drinking it, but I don't want to drink while I am talking. Right. Oh, awesome. Simon, it'd be good if you did make it
Mitchell
along.
R. said if it's yesterday, next week, next year, or in a decade, as long as the final result is complete, then it is complete lol.
Yeah, that's right, Mitchell. It'll get there. Yeah. Thanks, Tassie. I appreciate that you find it interesting.
Aaron Knox said, this is a public service announcement. Fusion 360 Health Dashboard confirms the maintenance team confirms Autodesk products are too expensive.
Yes, perfect timing on the outage. All right. So, let's get back to this. All right, so power supplies. If I go back to the PCB now, there's going to be a whole bunch of extra capacitors to be laid out. All right, so we now have, first sheet has just the USB hub on it. Third sheet has all of the power supply stuff on it. Second sheet has the MCU with the CAN bus interface and the Kayo serial interface. Good one, Graham. Graham said, "Are you sure that generator wasn't powering the Fusion 360 cloud service, Mitchell?" Yeah, maybe it was. No, this outage that it's reporting is because they are doing, so this orange thing says that they are doing scheduled maintenance. So they're doing some software update or whatever on the cloud service, or releasing a new version of Fusion or something like that is what's actually going on. It's a scheduled thing. And my local running copy of Fusion says there's an outage because it is failing to communicate with the API of whatever they're using on their back end. Now, so what was I doing? All right. I do need to finally assign these nets to useful things. Okay, so I need to
Aaron
assign...
Knox said the outage is so they can balance their books and count all their cash.
I know we're doing a lot of Fusion 360 knocking here and Autodesk knocking, but the thing is, I do actually like the product. I don't mind paying for it. And for what it is not excessively expensive. It's yeah, it is a good thing. But what what frustrates me is dealing with cloud services.
Mitchell R said pins 1, 2, 3, 4 laughing face.
Pins 1, 2, 3, 4. Yeah, we'll just put it on the first ones. 1, 2, 3, 4, and we're done. Now, one of these is a strapping pin. I think IO3 is a strapping pin on the S3. So, ESP32, ESP32, S3, strapping pins. Where are we? Okay, so. No, this was just some, I just did a quick search for strapping pins because I wanted to see what they were. So it's pins 3, 0, 3, 45, 46 are the strapping pins. All right, let's do, come on, Superhouse, where are we? Symbols, supply symbols, NC. What did I just say it was? So IO0, of course, which it already is. 3, I'm going to stick a no connection symbol on there. And was it 45 and 46? I think it was 45 and 46. Let's see. 45, yeah, 0, 3, 45, 46. I'm just sticking no connect symbols on those pins, just to remind myself that those are strapping pins. Austin says, don't forget the PS RAM pins. I made that mistake on my recent boards. Oh, interesting. Which are the PS RAM pins?
Says, don't forget the PSRAM pins at Superhouse TV. I made that mistake on my recent boards.
Hang on. I just noticed that was spoken, but Austin didn't say. Was that manually triggered? Is there a way to manually take comments and say them? I don't know. Anyway, Yes. All right. So, wow. Where are we? Oh, okay.
Mitchell R says for mods, if you tell an at the person, it will force say them slightly smiling face.
Ooh. Okay, if you tell and at the person. Right, okay. Thanks, Mitchell. Now, wow. I was just thinking, Mitchell has built this really awesome tool doing all of the voice stuff in far less time than it's taken me to do the schematic for this project. All right. Now, back to where was it? And Trady said datasheet time. We've all made that mistake. Yeah. So, Austin. I see. Yeah, at Tell Austin's Creations. So, Austin says, don't forget the PSRAM pins. I made that mistake. So the PSRAM pins are these ones, I think. Is that right? The TCK, TDO, TDI. I don't know. Oh, Austin's checking notes. Okay, cool. I have a feeling it might be this clock data out, data in, this set of pins right here, which I think is the second SPI bus. So we've got the primary SPI bus up there, and we've got the secondary SPI bus down here, which I think is the one that's used on PSRAM. Could be wrong. I will see what Mitchell says. Yeah. All right. Now, but that doesn't stop us from doing stuff. All right. So I can just assign some pins down here. What am I going to do? SDA and SCL. What pins should I use for I2C? For simplicity, I am going to use, in fact, just to keep it consistent, I like to use the same pins if I can. Oh, okay, so Austin says on the ESP32 S3 Vroom, it was pins 35, 36, 37. Ah, 35, 36, 37. This is a Vroom.
Austin's _ creations says on the ESP32S3 WROOM1UN16R8 ICI used, it was pins IO35, 36, 37s.
IO 35, 36, 37. But is that... Yeah, but those are the regular SPI pins. That's odd. Like, that's the normal SPI. Anyway, I'm going to avoid using those. So I'm going to... Yeah, I'm going to mark those as don't use. I don't need SPI for this anyway. Oh, hang on. I do. Or don't I? I do. Don't I? No, I don't, because I'm I'm using the, I'm going to use the internal CAN controller. So what I've got is CAN TX and RX. So it's what Espressif called their TWAI, which is their two-wire automotive interface, which is just a CAN bus, but you've got to pay a license fee to call something CAN. You've got to pay the whoever the association is. So they've implemented CAN bus and then called it two-wire automotive interface, just to avoid the license fees. So if I was using an external CAN controller, I would need SPI, but I'm not, so I don't. So I'm going to leave that. So I'm going to mark the built-in, like SPI1 as don't use. All right, now back to I2C. Now, I'm going to use the same pins as the Adafruit ESP32S3 Feather, which also happens to be the same pins as I used on another project for a client just recently. So I've just got this on another screen. Where are we? Where? What did I'm going blind. I can't see it. Hang on. I'm going to bring this up onto here. So where do they even note it on here? Crystal. Did they note SCL and SDA? Yes, they did. Okay, so what they are using is 3 for SDA and 4 for SCL. Okay, so 3 and 4 for SDA and SCL. 3 and 4. 3 and 4? 3! That's one of the strapping pins. Okay, no, I think that's alright though. So I think if we use that for data, even though it's a strapping pin, it is okay. So 3 and 4. And it was, let's give them names that make sense. IO3 SDA, IO4 SCL. Okay, and that means I can get rid of this. Am I even using I2C? I don't know why I've got... Oh, it's gone! I was just doing a pinch zoom then, and all of a sudden it has it's gone somewhere. I don't know what happened to the schematic then. It just vanished off the viewable area. There are so many rough edges in the UI. Am I using I2C anywhere? I don't think I am. So what else? No, that's just regulators. That's just the USB. No. Okay. Well, I'll leave those nets on there as designators just to show. In fact, what I'm going to do is leave. Maybe this will be confusing, but I do this a bit. I'm going to put do not connect symbols on those 2 pins, even though I've got nets associated with them. Just in case I do use I2C somewhere, then I've got those pre-assigned. And then I'll just remove the no connect. Yeah. Austin says, which means add a quick connector. Stephen says if the desired state is high, the I2C pull-up will keep it correct during power-up. Yeah, I don't. You're right. I don't have any pull-ups on here. Maybe I should add pull-ups on this and a quick connector just to make Austin happy because Austin likes quick connectors. Yes. I2C to add future OLED or LCD. Yeah, says Henrik. Now, what is IO3 doing? Oh, let's move that out of the way. Where was I? Where is IO3? Is it meant to be a pull-up? Where is it? Where is it? Where is it? GPIO3. Can't tell if there's anything associated with that on that schematic. Alright, let's do ESP32, S3, IO3, strapping pin. Just see what we can find. Hardware design guidelines. Alright, IO3, where's strapping pins? Strapping.
Scott Miller says Austin has a chitch fetish, rolling on the floor laughing.
Yep. That was funny how the speech synthesizer pronounced it as chitch instead of quick. What am I doing? Strapping pins. All right. It's covered in there. Strapping pins. So 0 and 46 are defined there. I want to know what IO3 is doing. What does IO3 do? Maybe it'll tell us if I click on that. Strapping pins. Floating bit value. Alright. IO3. What does IO3 do? Come on. don't just tell us it's floating. Yeah, default configuration is floating, bit value is undefined. What does it do? GPIO3. Okay, let's try. GPIO3. This is gonna find matches on like 30, 31, 32. Maybe I should do a search for GPIO3 space. IO marks. No, come on. Come on, come on, come on. What is the strapping pin purpose of IO3? It's going to take forever. Let's see. Yeah, I'll do a search for GPIO3 space. Low level glitch. That, not that. RTC GPIO3. JTAG signal source. Aha. Okay. JTAG signal source. So that's what it does. But what? JTAG signal source. Determine a bit. So if we if we apply a pull-up resistor on that, as an I2C pull-up, what is that going to do? I think it'll be okay, because if it's not running JTAG, it'll just be constantly high. So, I don't think it changes the boot mode. It looks like it's only JTAG related. JTAG signal source control. Okay. Strapping pin GPIO3 can be used to control the source of JTAG signals during the early boot process. Does not have any internal pull-up. That cannot be in a high impedance state. Okay. So if it is high, it's USB serial JTAG controller. If it is low, it's JTAG pins on those. Okay. And that is if these two fuse bits are set low and this fuse bit is set high. It's ignored if that fuse bit is not set. Well, yeah, it's ignored and it defaults to USB serial JTAG controller. Okay, no, I think this is all right. So what's going to happen is, if it's pulled high, if we use IO3...
Aaron Knox said at Austin's_creations.
John, too tired, you got to go. John says, much as I'd love to stay with the live stream, sadly I'm too tired and need sleep. Yes, have a great day everyone, and leave enough to do for next week. No, next week we have robots with Josh. So it's going to be different next week. Yeah, so Trady says, this is what's needed to recover firmware, I believe, John. Yes. That is, yes, that's if we're using JTAG. But I'm not intending to use JTAG on this, and if that fuse bit is not set, or if it is 0, which I think is probably the default.
Creations says I have a pull down on mine and it still pulls it high.
Oh, interesting. I have a pull down on mine and it still pulls it high. That's odd. That is odd. Okay, so Austin, do you think it's okay if I leave it, if I put a pull up on it? I suspect it will be. All right. Yeah, okay, so just to quickly recap, if these eFuse bits are all set to 0, none of this matters. GPIO3 is ignored in terms of being a mode pin. If these fuse bits are set, these particular combinations.
Creations said I believe so.
Yeah, cool, thanks Austin. Then it's ignored and it makes no difference anyway, because the mode is set by these fuse bits. The only situation where it matters, the only situation where it would be a problem if we're pulling it high and we want it to be low, is if we had these fuse bits 0, that fuse bit set to 1, and we were pulling it high, and we wanted it to be JTAG. So, all good. I think we're fine. Yes, I think we're fine. All right, so let's... I'm kind of tempted to... in fact, I'm going to do it. Oh, no, I didn't want that. I wanted... move. I'm going to stick a couple of pull-ups on there. Doesn't fit there nicely. Let's go for 4K7 because that's the standard sort of pull-up. Why is a designator off there? Why? What? That's a weird position for the designator to be in. It must have just been because it was... Yeah, what's with the grid? If I move that, it moves to there. Strange. Alright, let's make that... Let's just move it half the distance. We're going to break the grid. That's better. And now I'm going to stick my grid back to 0.1 so I don't break everything else. Copy that. No, I don't want to copy that. I want to move it. In fact, I want to move these down here somewhere. No, I don't want to connect those. Oh, this rubber banding, I don't like it. I don't like it. How am I gonna do that? I can do a split off here. No, not that. Come on, I'm pressing escape and it wasn't getting out of the tool. This is nasty that I have to do this. But I'm fighting the rubber banding. Oi! What happened then? That got detached. What?
Chassis Bob said, Lex, I turned the lights off.
Oh no, we're back to that. Oh, stuff this. I'm just going to delete these nets. We're back to that game from last week. Alright.
Henrik Ostrov said, "Hi Siri."
That's safe because I don't have Siri turned on. You can do that if you want to. Ooh. Okay, so we've got a couple of pull-ups on there, and we'll make these nets again. Was it SDA and then SCL? I think it might have been 3 as SDA, IO3 SDA, IO4 SCL, IO4 SCL. Is that what they did? Yes, that is what Adafruit did. So, can bring these ones down. Now,
Amanda Thompson said, "Lex, turn the lights off."
the lights are already on. I mean, they're already off. It's not working. Siri can't even tell us how to hide a body anymore. Yeah, the robots are so unhelpful. They won't assist us in committing crimes. Now, Kayo RX and Kayo TX. All right. So we've got CAN RX and CAN TX. How long does it take me to hook up 2 nets? This is ridiculous. All right, so I need a piezo. No, she who shall not be named is not even like, ooh, Henrik, what is this going to do?
Henrik Ostrov said, "Ohayu gozaimasu, ideographic comma."
That was interesting.
Amanda Thompson said 20 minutes to lunch.
Did the voice just change? It sounded like the voice changed. The voice changed. Oh, Justin said insert SQL injection here. Yeah, people were trying that last week. And I think maybe JavaScript injection was attempted last week. All right, I need to pick 3 pins. The piezo and that. Now, there was a piezo module. What did I
David Crisp said last
do?
time the voice was different for each say. Was kinda cool.
Oh, okay. So the voice changes. All right, I am going to give you a close-up on my ugly face while I open something in Fusion 360, because I'm going to open a project for a client. Which one is it? Logic or IO? That one. Yeah, this is a client that I can't even tell you that I'm working for them, let alone what I'm working on. So I'm just opening the...
Henrik Ostrov said, Buenos dias, mi Jonna.
So I'm just looking up the pin assignments that I used on that project. So I used IO14 for the piezo, and I'm just going to use that same one again. Now, serial comms. What should I use for serial comms? All right, I'm going to close that, and I'm going to close that and come back here so that when you see the screen again, there is no evidence of what I was looking at. No, it didn't even try to pronounce that, Henrik. Henrik is experimenting with different character sets and languages to see what he can achieve. Oh, hang on. I'm going to...
Knox said, Tob nizama salatum siht neas yrt.
Okay. Logic, where is the schematic? IO14A4, it is. IO14A4. Alright, back to Superhouse projects. Come on, I've got to be able to find it. Superhouse, here we go, and there. Okay, so now we can come back to here. And back to here. Now that I've got out of the super secret project. And this one is going to be IO14A4 piezo. And then I can get rid of this. And then on, where is the piezo? Over here. IO14, okay. So we'll join this up. IO14, yes. Thank you, autocomplete. And
Henrik Ostrov said ni hao ma. Aaron Knott
So what's
said
the...
UZS LLSUS.
So Henrik said ni hao ma. What is the response to that? 我是很好. My pronunciation was probably terrible, but that's me putting a positive spin on life. Now, well, yeah, I can never get the tones right. What is it? 我是很好. So, Henrik, 你好吗?
Henrik Ostrov said Chinese works yay.
Yeah, it is. It did. I even understood it. Okay, we've got the piezo. Last to is yeah, I can understand some of it. I just can't say it. When I try to speak Chinese to Chinese people, their reaction is, "What did you What did you just say?" I can understand it just slightly better than I can say it. I can never pronounce the tones correctly. So IOX, KO. So I need, all right, TX and RX. What am I going to use for TX and RX? It doesn't even really matter. Oh, Mitch says, John, your pronunciation is good enough. Oh, cool. Thanks, Mitch. Yeah, Mitch speaks Chinese. Very, very useful when you're traveling in China with Mitch. Mitch, we've got to go back to China sometime. I really want to go back. What am I going to use? I'm at the point of just randomly picking IO11 and 12. Now, this is something that I haven't really got to the bottom of with the ESP32S3. So we have TXD0, RxD0, and how do they interact with the USB interface here? All right, I am going to... Graham says, I like German because you can butcher half of it and they'll still understand you. Yeah, German is like that, isn't it? Oh, I think I might have told this story before. A funny thing happened to me a long, long time ago when I was in Germany for a conference. And I was, this was for Linux Tag, which is Linux Day in Germany, like Tag, because you've probably heard of Guten Tag, which is good day, and Tag is just day in German. And so Linux Tag is a conference that used to be in a city called I can never pronounce this, I can't get it quite right. I can't get the R right. So I'll say it the English way, Karlsruhe. And late at night, I was trying to get a taxi back from somewhere near the conference venue to the place that I was staying. And so there was a taxi stand.
Alexi Kola said Morse anti-pudem.
Where there were a whole bunch of taxi drivers sitting around. This was late at night, like 10 or 11 o'clock at night. And I walked up to them and asked them if they spoke German instead of asking them if they. I think I said, "Sprechen Sie Deutsch?" Asking if they.
Aaron Knox said, "You so stopped yourself the first time mimicking the accent."
You so stopped yourself the first time mimicking. Yeah. It's a fine line because trying to do the accent is kind of, it's not mocking, it's trying to be understandable. 10 minutes to noms. Okay, I've got to get these things done. I'm just going to see if I can save this or if it's going to fail.
Said Mein Deutsch is IST Skizzer.
Mein Deutsch is Skizzer. So your German is, what is Skizzer? I don't know what the word Skizzer means. Oh, it's probably actually pronounced Schizzer? I don't know. Ah, is it, my German is shit? Is that literally how, is that literally how it's translated?
Yet they placed a banner advising you in advance.
Scheiße. Scheiße. Yes. Yeah, that's the thing with German is that even not speaking German, you can kind of understand half of it. All right, back to here. All right, I am going to do the same thing again. I'm going to switch to a client project. This is a different client project.
Sauerkraut cupcake semi-soft-tiger marmelade.
Ooh, that actually sounded really cool.
Peter Lawler said, when ist das Nunstückt und Slaughtermeyer? Ja, Bayerhen, das oder die Flipperwalter Sput.
Yeah, so our tradie said classic tale. You have to be yourself though. Yeah, I was what's the word for English in German?
Amanda Thompson said auf Deutsch sprechen.
So yeah, what I wanted to say was, do you speak English? And I said, do you speak German? And so they're all sitting there. There must have been like 4 or 5 taxi drivers sitting there, and they all started laughing. And then one of them took pity on me and yeah, drove me back to the accommodation. So what am I doing? I am opening another client project. This is a client project that is it that one? No, maybe that is not in... This one might be in Eagle. I have a feeling this project is in Eagle. Okay, I'm going to open Eagle so that I can look up off English. Ah, okay, so Sprechen auf English. So is English? Amanda just retracted that message. Probably to do it again with the... Yeah, David said, yeah, so you walk up to them and say, hey, do you speak English? I'm from Australia. Yeah, that's what I should have done. Hey, mate, I'm an Aussie. Yeah, I'm an Aussie. Yeah. I hate the Australian accent when it's like that. And now half the people just left the chat. Clients, I am looking in.
Amanda Thompson said spreken auf English.
Oh, that sounded cool. That was like a Spanish person speaking German. And that was what that accent sounded like. I am so distracted. What I'm trying to do is I'm opening a client project because I want to see the serial port pin assignments on an S3. This was a different S3 project, which is why...
Wenn ist das Mundstück GIT und Slaughtermeyer? Ja, Bayerhund das oder die Flipperwald-Gersput.
Okay, I missed that because...
Outside the box said io doppia iago in mate.
I love the accents on this speech synth. All right, what am I doing? You're making me lose my mind. System notification.
System notification, 5 minutes remaining.
Ah, I am losing my mind.
Henrik Ostrov said Zon, Superkrate Insena Electronic, Shozi Naraj Steiner.
All right, so IO43 transmit, IO44 receive. Yes, and they are being used.
Said Steve.
These accents are awesome. Okay, so I can use... Sorry, you can't see what's going on here. I'm going to switch back to here now that I have got the... get that off the screen. Now that I have got this back, so I'm going to use IO43 and IO44 for this. Oh, I have been...
Peter notification, I have been activated.
Peter has been activated. Alright, so I want IO43 for TX. So I'm going to go... No, not that one. I want name, IO43, IO44, IO44 for RX, and I want IO43 for TX going to the Kayo interface. And then and then I can get rid of these dangling nets over here. Bang bang. Okay, now
Detecteur notification. They have been deactivated.
so now we've got all of the nets assigned at least. I think amazingly we've got to the point where the schematic is pretty much complete. It's not neat, but it's complete. Oh, hang on, what have I got? Let's...
I've never done that.
Yeah, RX and TX messed up. Never ever. Alright. On our to-do list. Find inductor with a 2 amp plus rating. Okay, I've already replaced the inductor. Place connectors on board edge. Yeah, that's just going to be part of our thing. Match up nets to SP32. We've done that. Check section 10.1 for USB decoupling. What was section 10.1? Consider HDMI USB plugged in clearance. Ah, right. Yeah. That is an interesting point. I think I'm going to ignore that one. So what that was actually about was, if we go to the board view, and we've got USB ports over here, and I want to plug in one of those little FPGA based HDMI capture devices, little dongles that are like a big memory stick with an HDMI socket in the end, and I plug it into one of these USB ports. It's going to physically take up a fair bit of space. It's going to be like here, and they're quite wide. So if one of those is plugged in, does that then get in the way of the adjacent port? And the short answer is probably yes, but without making this whole thing physically a fair bit bigger, I don't think I can really... Well, maybe I can move this down a little bit because we don't need much. We don't need much clearance here for a screw head. So with this sort of arrangement, this might allow enough room for... I have no idea what you said, Henrik. Amanda said, I've just ordered pizza for lunch, so you have 20 minutes extra time. Whew. Okay, 20 minutes extra while Amanda waits for her pizza. Alright, so there might be room there. I'm not going to go to the trouble of actually measuring this because I see this as a very secondary thing.
System notification. Stream is over.
Time up. No, time is not up. Time is up. No, it's not up. Because if I do have an HDMI capture device plugged in here, I think I would have it on an extension cable anyway, like a USB extension lead plugged in here, going to the capture device that would be somewhere else in the machine. So I think I'm going to pull it down in order to give a reasonable amount of clearance between these two USB sockets, but I think that'll be enough. So yeah, okay, that's what that note was about in the to-do list. Now, wouldn't it be unfortunate if after doing all of this, I could never actually save any of this? Because what I'm hoping is that once the cloud service comes back, I will be able to save. If not, I might be able to save locally, save as a local file, like export as an Eagle file or something. Although, I wonder if, let's see, file, export, will it allow me to export? If I go to Eagle board file, is it going to allow me to do this? Let's just try this on the desktop. Export without the cloud service being active. Yes, it did. Okay, so I can actually save files locally while the cloud service is broken. So that's all right.
Peter Lawler said, are you still here?
Yes, I am still here, Peter. I am still here. And you can't leave either because I'm still here. What? So Trady said, make something you can shove on the DIN mount rack. I've picky on my YouTube channel how I modded a new compressor. Oh, right. Yeah.
Aaron Knox said, I need your clothes, your boats, and your motorcycle.
Aaron.
Apostrophe series all my candy eaten.
That was, yeah, Aaron was trying to set the
Outside
accent,
the box said Peter has left the chat.
and it didn't work.
Gavin Jackson said your Visa, Westpac, Vodafone, Combank, Optus account is showing unusual activity. Please call for a human representative.
Oh, and Henrik asked, are all my candies eaten? Yes, they were eaten a long, long time ago. Did you really think that you could send me candy and have it last this long? Oh, look, it just came up with a message. Export of OpenBlah is ready. All right, I'm going to just try saving again, see if it works. Version. Yeah, I think the cloud service is back. All right, it is. Well, at least they were accurate. They said it was going to be out. That was actually shockingly accurate. It is. They said that it was going to be out between 11 and 12. It died pretty much exactly at 11, and it just came back a minute ago. It's now 12:03. So their cloud service was out for exactly the window that they specified. So at least at least they were accurate about that. That's good. I may not like it, but at least it was predictable. Oh, Mitchell has just listed all of the accents that are available. What am I doing? Okay. Now, back in the to-dos, there was also the, I didn't even mention, so check section 10.1 for USB decoupling. What was USB decoupling? Section 10.1, I think, was of the data sheet. And where is the hang on. Where is the USB thing? I think it's on the wrong sheet. Wherever the USB socket is, I need to move it onto this sheet. It's not on that one. Oh, I know why. It's because it's not a USB socket. It is just a connection to this. So it's DP3 DM3, and the USB socket is up. Oops, is up here.
Henrik Ostrov
right.
said, hi, AliExcar.
Trady says, I'm just happy you didn't lose your project. All right.
System notification. Peter is angry. 5 minutes ago.
Peter is hungry. Grab a snack, Peter. Yeah, I'm going to wrap it up in a second. Because, as I said earlier, I do have to do a lot of client work before tomorrow morning. Because I'm going to have people on the phone saying, is it done yet? So I've got DP 10.1. Yeah, I'm sure that note made sense to me when I wrote it. It doesn't make sense to me now. I should have written a more detailed note. Section 10.1, USB decoupling. I think that was the data
Peter
sheet
Lawler said, is it done yet?
for the TUSB. Peter and Amanda both had almost the same thought. Is it done yet? Are we there yet?
Michel R. Said Purple Squirrel.
All right, I want to see what Aaron's comes out like.
Henrik Ostrov said, I need your macaroni today.
Peter Lala said, is it done yet?
Gavin Jackson said left your homework till the last night again, John.
Yes, I did leave my homework to the last night. I'm cramming before the exam. It didn't say Aaron's. I wanted to hear Mario. Alright, check section 10.1 for D. What was section 10.1? I think that was the data sheet of the TUSB. Let's see, TUSB PDF. Is this the data sheet? No. What is that? TUSB. No. Okay. I found someone's. I just did a search on my local computer and I found a BOM TUSB 8041. No. Where? Not that one. I'll get rid of that. Get rid of that. Where is this? Oh, wrong. There. Alright. It is a TUSB. I'm just on a different screen at the moment. I'm going to look this up. TUSB 2036 VFR. And bringing it up here. Here's the data sheet. Section 10.1. Maybe this is what it was referring to. 10.1. TUSB power supply. No, I don't think this was it. All power rails require a 10 microfarad capacitor or 1 microfarad capacitors for stability and noise immunity. Can be placed anywhere on the power rail. Should be placed as close to the power pins as possible, with an optimal grouping of 2 of differing values per pin. Well, that's a pretty stringent requirement. Okay. I think I'm going to say stuff that. Okay, so what they were wanting was decoupling caps close to the TUSB. All right, did I put any nearby? Got some there, got some there. Let's put some here nearby, just to.
Earth is the planet we live on. It is
Alexa, stop. Where did that come from? I didn't. She who shall not be named just started telling me what Earth was. Where am I looking? I want to stick down. Yeah, I'll stick down at 10. What will I do? I'll stick a 10 microfarad right near it.
Aaron Knox said Amazon.
Mitchell R said, it's a me Mario.
It worked. It's a me Mario. Come on, scroll. What am I looking for? Capacitors. That's right. I just want a cap. I want an 0805 cap. And I want to stick it there, and I'll stick another one there. What do we give them? We'll say these ones are 10 microfarad. Why not? 10 microfarad. 10 kilo microfarads. Isn't that just a farad? A kilo micro is a 1. I need a ground symbol. Need a ground symbol. Yeah. Approximately 10 kilo microfarads. All right. So they can be the decoupling caps that are near the USB hub. Now, where did it put these? Was it these two? 10 microfarad.
Aaron Knox said, yeah, it's a me Mario. It's a time for pizza.
It is indeed time for pizza. What am I looking at? C23, C24.
F-Bombs Electronics Repair said, Did it specify the type of cap? Sometimes they say 1 UF tantalum or 10 UF electrolytic, etc.
That's a good point. Without reopening the datasheet, I don't think they did. I think it just said 10 microfarad and 1 microfarad near the pins. Oh, hang on, let's I've got the designators layer turned off, so let's just see that. That is C24 and that is C23. I don't even know which ones I'm looking for. Yeah, 24 and 23. I did have the right ones. All right, so let's move these over here, right here somewhere. Now, where is the 3.3 volt rail is passing through from a bottom layer, and it is there. Which pins do we care about? Oh, we've got a bit of space. Let's stick one. I've got 100 nanofarad coming off the power rail there. Let's stick another one over here and one here, largely because there's space. Stick one here. And we'll stick another one maybe. Yep. Does that sound good to everybody? Right about there? Yeah? No? Maybe? How is our... Yeah, that'll do. Okay. And what am I going to use? 3048 tracks. Yeah, that'll do. Okay, so we've got a couple of decoupling caps on diagonally opposite sides of the 3.3 volt rail, which is linked all the way through internally here, and it's linked through to the... We've got an entire plane of 3.3 volts. So what I should probably do is also, just for the hell of it, stick a via right there coming off, because that's a 3.3 volt via, like that. So we've got a hard link to the 3.3 volt plane next to the decoupling cap. That should keep it all very well bonded to 3.3 volts. Now, what have we got here? Oh, that's the oscillator. Yeah, let's do that. Stick that one in. Boink. Then, oh yeah, stick you in as well. Then, what can we do? Yeah, so we're still at the stage of like bulk moving stuff around. All right, we haven't resolved this power supply thing. Now, all of these, I think, are the extra caps. Oh, 4K7, that's right. Okay, so we added in a couple of pull-up resistors. Let's just move those over near the... We'll move those over near the pin where do they rubber band to? Up here. Did everybody hear my stomach then? You probably did. And these caps are going to be associated with this part of the board around the 3.3 volt switching regulator. What have we got? CAN bus there. Yeah, I could move that up to make a bit of space. We've got lots of room. Move this up here a bit. Which gives lots of room in here for decoupling caps, and let's just move these up. Oh, no, move. We'll stick them up here, and then they can all be arranged. Where does that go? 10 microfarad. Yeah, let's stick some 10s in here. I'm just gonna stack them up. Stack them up. That one. There. That one. There. And that one. What is that one doing? That's... Oh, that's on the output side of the 3.3 volt regulator, I think. Must be. That looks like it's linked to the 3.3 volt rail. Yeah, okay. Cool enough. cool enough. Oh, and there's already one there. Okay, so it's just in parallel with that one. Oop. Like that, approximately, give or take. All right. Where are we at? Still kind of messy in terms of part placement. Oh yeah, quick connector. Am I going to stick a quick connector on here or am I not? I don't know that I want to. I don't know that I care. I'll leave these pull-ups on I2C. But the thing is that this is a single purpose board. It's not really going to need a quick connector for other things to be plugged in. At least I don't think it is. What is that cap doing? Sitting out there having a picnic all on its own. Yeah, so now... Alright. Time for everybody to tell me the things I'm doing wrong with routing. What am I doing? Oh, is the bot broken? Maybe. I'm reloading it. Alright, I am going to stop. I'm going to stop. Broken or just turned off. Oh yeah, bad gateway. I just tried reloading it and it says that it's broken again. Ah, quota maxed, says Mitchell. Ah, that's a pity. Alright. Now, where am I? Back to here. Back to here. Alright, it needs a bit of, a little bit of shuffling. And I have to resist the urge to try to make this board as small as possible because we've got all of this blank space. Look how much space there is here. All of this blank area all through here. This whole board could be made probably a third smaller without a huge amount of effort. But it's largely constrained by the... Yeah, maybe... if that moves to there, that moves to there. I could take that up. Maybe I can make the board a bit narrower without, yeah, without compromising anything much. But the point I was about to make and felt, what are these caps doing? What are they doing? I don't even know what these are for. Are they meant to be part of, oh, that's, oh, I know. That's just the power indicator, and this one is meant to be up here because it is next to the 3.3 volt rail on the vroom. Alright, the point I was kind of going to badly make is that for something like this, it is not worth the time to optimize for size because it doesn't matter. It's going into a physically large machine. I could take time to make it smaller, but who cares? So now if I move that, if I move this up slightly, so if I move the USB hub portion up slightly and left, or just move it up, then I can grab all of that and move that, and then if I move that, yeah, let's do this. It is actually extremely low effort to make this board smaller, quite a bit smaller. So let's do it. Then I can move the USB hub portion, where am I going to move it to? Move it here somewhere. Yeah, that'll do. Move that, and then, oh yeah, this, what is that? Oh, that's the, is that a reset button or the boot button or something? Anyway, all of this can then just move left, like this, blink. And because of my OCD, I don't like it when these end on odd things. That's 82 millimeters. If I could make it 80 millimeters, I would be happy. Yeah, stuff it. Let's make it 80 millimeters. Move group 80, and then I'll make it fit. All right, 80 millimeters by 32 millimeters is the current dimensions of the board. And then I'll just do a little bit of shuffling in here to make that fit more nicely. You can see that it kind of doesn't fit there. Oh, I can make that fit easily. I can just bump all this left a little. Can I still route those tracks? Just looking at that. If that goes there and that goes there, then that track will go there. Yeah, that'll work. Okay. There's still room. Yep. All right. So it's now 32 millimeters by 80 millimeters. And there's still heaps of space. You know what? That's just room to stick Steve on the board. I can put a big picture of Steve's happy face on here. Yeah, okay. Probably a reasonable place to stop. Now, as I kind of half mentioned earlier, next week we are going to have a... definitely not 80 by 32. No, it's not. I must have been looking at the wrong thing. Hang on. Where am I? If I go up to here, it is 80 by... Hang on. What is the position of that? 70. Okay, it's 80 by 70. You're right. 80 by 32, the aspect ratio would have been totally different. It would have been more like that sort of dimensions. Well, even less. No, it would have been more like that sort of aspect ratio. Yeah, 80 by 70 is the current dimensions. Now I'm going to get rid of that. And so, next week, it's going to be different. I am not going to be working on this project. I'm sure you're all sick of it anyway. We are going to have a special guest. We are going to have JC on the stream showing off a robot, and all the details of that I'm going to... So because I know in advance what it's going to be, I'm actually going to schedule this one pretty soon. In fact, probably today I will put up the schedule for the next stream. Audio sync is out. Sorry, I was just seeing the thing about DIN rail stuff and my brain just diverted temporarily. All right. Forcing myself back onto the golden path. Next week, Josh is going to be on the stream and we are going to be talking about robots and specifically Josh's robot projects. So there's going to be some cool stuff. We'll have some video, I think, of robots in action. So I am going to, yeah, I'll post the stream. And come along and see what Josh has been doing. Yeah, that'll be fun. All right, it is now 25 minutes past the witching hour and my stomach is going nuts. My brain is failing and I'm sure you all want to be somewhere else. So I'm going to go. And thank you for coming along and putting up with my mental spottiness today, and I will do my best to make sure I get more sleep before I have Josh on the stream so I can ask sensible questions and follow what's going on. And thank you very much. Where's this button? Here it is. Okay, thanks. Bye.